Okay, let's take a look at Chapter 20, Objective 4. Well, that's supposed to be Objective 4. There we go. Now, Objective 4, Chapter 20, is going to go over blood flow, blood pressure, and resistance and how they work together with each other. So, one of the things you need to know is the relationship between resistance and pressure. And they are inversely proportional. So what that means is if you have a high resistance, that means you're going to have a low pressure. Okay, so they're going to do the opposite. If you take a look at this picture right over here, this graph, you can see the pressure is over here on the y-axis, and the pressure is 120, then 100, then 80, so it's decreasing here. What you're looking at in this first part of the image, you're looking at the blood pressure in the aorta. Now, the aorta, is that blood vessel that's going to be under the most pressure because it's coming straight, the blood is coming straight from the left ventricle and it's then entering the aorta, so it's going to be under the most pressure. And you can see it's got a lot of pressure in it as opposed to the rest of the blood vessels. Now, if you look at this black line kind of in the center right here, that's giving you that mean arterial pressure. It's the average of the systolic and the diastolic pressure. And if you look at the aorta, that mean arterial pressure pretty much doesn't change. So the pressure in the aorta pretty much stays the same from the beginning of the aorta to the end of the aorta. And then as that blood, you can kind of see it trails off a little bit as you enter into the arterioles. When you get to the capillaries, this area right here, you can see that the pressure has dropped dramatically as you, and again, it changes. So if you're looking at the arterial end of the capillary in comparison to the venous end, the venual end of the capillary, you can see right here, just in comparison to the entry and exit of that blood in the capillary, you can see that this is under high pressure, so it's going to be low resistance on the arterial side. But when you get to the venual side, that's going to be under low pressure in comparison and have a high resistance. Okay, and that's just looking at the capillary. Lots of changes within that capillary as blood moves through. Okay, you do need to know the information in the chart here. It just kind of puts it all. I didn't put anything about the veins on here, but we did talk about arteries, about the aorta. You can see the blood pressure, average mean arterial pressure in the aorta is about 110, 100, 110. So because, again, if you look at the various pressures here, that is under a very high pressure, which means the resistance is going to be the opposite. It's going to be very low, okay? And take a look at the diameter. You also have, in comparison, a very large diameter in comparison. Now, as you go to the capillary, you can see right here that the blood pressure goes from 30 to 10. So this is at the arterial end of the capillary as the blood is entering. This is at the venous, the venual end. I don't know why I keep saying venous. The venual end of the capillary as blood is exiting. So that's why that's going on. And again, in comparison, even at the arterial end, it's like 30. So it's pretty darn low. So you're going to have a pretty high resistance and a very low pressure in comparison to the other blood vessels. And take a look at that diameter. Very, very small diameter. So you do need to know the relationship. You don't have to know the specific numbers, but you do need to know the relationships. You do need to know the definition of vasoconstriction versus vasodilation. Vasoconstriction is going to ultimately decrease blood flow. So if you're looking at normal, you can see right here that red area, that's going to be the lumen. That's where the blood is actually passing through. And then you have the wall of the blood vessel represented in that, beigeish kind of color there. Now, under vasoconstriction, notice the diameter of the lumen has gotten smaller. So it's showing you that the blood vessel is constricting. Take a look at the arrows. Notice what's happening here. And what's that going to do? Well, you've decreased the lumen. You've decreased the amount of space the blood has to pass through. So that's going to decrease blood flow. So vasoconstriction equals decreased blood flow. Conversely, vasodilation is going to increase blood flow. So again, if you take a look at that lumen, this blood vessel has been dilated. It's been opened up. Look at the direction of these arrows. I mean, it's even bigger than what you would call the normal up here, right? So vasodilation has occurred. That is going to increase blood flow. I mean, look at how much space that blood has to move through that lumen. Okay, now let's take a look at some questions. I'll give you a second to read those and answer them. So a large diameter blood vessel is going to have what kind of resistance? So again, a large diameter blood vessel is going to be something like an artery. So if we back up a slide, this is going to be your large diameter blood vessel. What do we know about its resistance? It's going to have a low resistance. So this is going to be B. The greater the resistance, the blank the blood pressure. So if your resistance is high, these are inversely proportional. That means they're going to do the opposite. That means your pressure is going to be low. So that's going to be B. And number 3, vasodilation. This is going to make the lumen bigger. What's that going to do to blood flow? It's going to increase blood flow. Okay, and that concludes objective for chapter 20.